All right, here we go. We got crablang and C++. It's going to happen. Let's do this. At what point does C++ become every language? When does C++ get curring in the syntax of OCaml? And at that point, could one argue you're always programming in C++ when it adds every feature from every language? Every language, every feature, C++, you're always technically programming in C++. Pattern matching, oh my goodness, pattern matching soon, really? Does this make it C++? Yeah, I've been programming C++. Look at this C++ going right here. Look at how good this is. That's because C++ will soon incorporate the what I like to call the Turok 2 light ship bad guy operator. It's a mouthful. Some people call it the walrus operator. This guy right here, instead of doing auto, you can just now do that operator, and it will just do auto for you. It's pretty great. C++ is going to take your wives, so you got to hide them, your children. The Turok 2. Yeah, it is Turok 2. Soon, C++ 2. Oh, damn. If C++ is so good, then why not make C++ 2? Too bad, bitches. It's already on to C++ 23, okay? They've made so many.
I don't know if it's because of the Rust lobby or European Union regulations, but C++ is about to become a safe language. The C++
Classic GDPRW. Is that what's happening right now? European Union once again regulating my American freedoms.
community has published a proposal for a safe C++ that would allow us to write safer code and spoil all the fun you can have with the latest C++ 98 standard. This proposal basically tries to bring...
Okay, so just in case anyone's wondering, just in case, when it says the latest standard 98, you guys are all like, well, dude, that's so old. There's plenty of new versions of C++, like the C++ 11, 13, 17, 20, 23. The thing is that though all these standards do come out, every company you ever go to work for still is on 98. So it still hurts a little bit. Or they're on that pre-C++ 11. You know how C++ 11 it wasn't just C++ 11. There's C++ 11 part 1 and then C++ like Return of the Jedi. And no one's on Return of the Jedi. None of them. They're all on A New Hope. And it's just emotionally painful. Just entirely skips the Empire Strikes Back. It's just awful.
Safety features from Rust to C++. But why not just rewrite everything in Rust then? Or why not write all new code in Rust? It can interoperate with C++, right?
By the way, I know we're barely into this, but there's this tweet this morning, and I just wanted to re-highlight it due to how amazing it was. Let's find it. We're scrolling. It should be like right here. This is, by the way, if you don't know who Justin Keys is the guy who forked Vim to make Neovim. He is the benevolent dictator for life of Neovim. So if you want to know who he is, like genuine badass, right? And they have decided not to do anything with Rust, but has actually decided to go with Zig. And look at this, even inside their pull requests or even inside their issues, playing around right here, they're doing this whole little Zig building wonderland right now, right? Where they're actually building and doing stuff in Zig as opposed to that. And I love what he says. Neovim artfully avoided the rewrite in Rust catfish, but instead they're just waiting for Zig. Now that, my friends, that's W material right there. That's W material. Again, Justin, why do you think he's the benevolent dictator for life of Neovim? Lua, good choice, Justin. You know, a lot of people probably would have went with JavaScript. Oh, that would have been fun. Imagine actually trying to integrate V8 into your project. That would have been a full-time job for a year plus. That would have been fun. No, instead you chose Lua, which took you a day, and then it took you about a year to make sure all the APIs are correct and coherent and, for the most part, match the old Vim style. Blessings, Justin, blessings. You focus on the good problems, always did the right thing. Tree Sitter, LSP client, Lua, the boy's a genius, okay? The boy's an actual genius. Sorry for the, I got really distracted there. I'm out here. I'm just in love, okay? I'm in love.
Right? Well, it's not that simple, and the proposal also acknowledges this point. Basically, there is way too much code to be rewritten, and the problem with interop is that Rust semantics differ quite a lot from C++, which affects the way the code is structured, and also would require basically every developer that's older than 45.
Hold on, we got to go backwards a little bit. Rewrite it in a slightly different C++, yet completely incompatible. That's funny. I'm loving this. Okay, I feel attacked. You should be. See now, C++ developer. Yeah, this is very, very good, by the way. This is really good.
Older than 45 to completely change his mindset. With this in mind, trying to bring safety into C++ seems quite reasonable.
I thought again, the Return of the Jedi C++, 11 Part 2. I thought that one, I really should call it Empire Strikes Back. It just doesn't feel good. Return of the Safety. They come with smart pointers. Smart pointers is like early version ARC and RCs and gives you a lot of the safety that you need. Because with a unique pointer, you effectively have a bunch of compile time and runtime guarantees. With shared pointers, you have an atomic int, and you ensure, smart pointers add some overhead for sure. Array is an early version of safety. Since we're on this Star Wars reference, Rey is a character that nobody likes, and so you saying Rey and me doing the Star Wars things, bringing up a mixed bag of emotions because we like Rey in C++, but not in Star Wars, so it's hard. Okay. Be a man, do it raw. Unique pointers do not add any overhead. Shared pointers do. Exactly, because shared pointers require an atomic reference because they're actually an arc, whereas unique pointers, I believe, are all compile time semantics.
That isn't the only such effort in recent years, though. Google, for example, has been working on Carbon for a while now. I plan on taking a look at it sometime soon too. Anyways, straight to the proposal, here are some properties that safe C++ tries to deliver. A superset of C++ with a safe subset, undefined behavior is prohibited from originating in the safe subset. The safe and unsafe parts of the language are clearly delineated. Users must explicitly leave the safe context to write unsafe operations.
Oh, it's kind of like the inverse of Rust. You'll actually have like a safe keyword in which you now have to operate in the safe world. I actually like I like opt-in safety. I do. I really, really do. I think Zig does it really, really well because you can use options if you want to, or you can use neopegs and void star that crap. You can also allow nulls. Like you get to kind of opt in. You get to kind of choose where your safety levels are. Safe is such a troll. Well, I mean, safe in the sense that you can't do the same level of memory things. When people say safe, this is the problem. By the way, this is actually one of my big gripes with Rust. Is people who write Rust keep saying the same stupid argument over and over again. If it compile, it's going to work. It's like no, it's not. It's not going to work. Okay, you're still a shitty programmer and you still produce shitty code. Okay, Rust isn't going to save you from that. Rust has never saved anyone from being a bad programmer. Safe simply means you're not going to accidentally smash your stacks. Okay, that's what that means. Logic errors will always exist. I've created memory leaks in Rust. Why? Because I forgot to delete keys in a hash map. Like that's normal. That's a normal thing. You have skill issues. I don't. I honestly think Rust would do a lot better in the public eye if they dropped that stupid mantra that everyone responds to, which is, oh, if it compiles, it's probably going to work. It's like, it's not a good mantra. Still need proper testing for runtime actions. Yeah, because there's the whole program side. It's not stupid. It's not stupid. It's literally true. It's literally true. All right, let's keep going.
The safe subset must remain useful. If we get rid of a crucial unsafe technology like unions and pointers, we should supply a safe alternative like choice unions? Types and borrows. A safe toolchain is not useful if it's so inexpressive that you can't get your work done.
That's truly the safest way. The safest programming language is the language in which you cannot add any more lines to. It's the safest line. It's the safest code, the one you can add to. Very accurate. I know. C unions. Yeah, so I would assume you'd get tag unions then, right? Because tag unions are more safe because you can't misinterpret what it is. I assume that is the, they call them enums, right? Enumerations, whatever you want to call it. Tagged unions, right? I assume there's just tag unions are considered safe. And STD variant, whatever it's called.
New system can't break existing code. If you point a safe C++ compiler at existing C++ code, that code must compile normally. Users opt into the new safety mechanisms. Safe C++ is an extension of C++. It adds a robust safety model, but it's not a new language.
Okay.
Safe C++ will be available under a feature flag, which makes sure the change is backwards compatible with older code, as everything is opt-in. This then enables a bunch of safety checks. The way it works is that it lowers the function definitions to the mid-level intermediate representation, or MIR for short, and it performs borrow checking on it, exactly the same as Rust. We'll then be able to use the safe keyword after a function.
Cool. My Go brain, when I look, by the way, when did it become func? Have I been out of C++ so long that func is now a keyword for function? Oh, yeah, sorry. You can't, okay, first off, you can never name a function func because my Go brain cannot see it. Okay? Literally, I could not see. I actually do not contain the ability to see it as anything but a function definition. And so I'm like trying to figure out how this works. Dude, cooked for sure. Yeah, dude, I did just entirely too much going right now. Entirely, dude, quiche eating. Bro, I've been quiche eating. All right, anyways, okay, so it's a function named func. Terrible name, by the way. Returns an int and is safe. And then you can do unsafe operations. And you can, so safe is a modifier on a scope. I think that's correct. So you can't increment a pointer unless if you're in unsafe mode. Is that what it's saying? Wait a second. Safe C++ is C++ that's not doing anything. So everything inside of here will have to be run in an unsafe block. So let me get this straight. You create a function that's safe, and then every last part of it is unsafe from there on out. Well, actually, if you write C++ at all, it's actually unsafe, so you have to wrap all of your C++ in an unsafe bracket. You start by calling the function safe, and then you wrap everything in unsafe. Yes, pointer operations, obviously this is unsafe. I don't think it's very... I don't think it's unintuitive to realize why pointer operations aren't safe, in the sense that when you add one to a pointer, is it within or without the bounds? Should be pretty obvious.
Function to basically restrict a bunch of smart-ass type of code in its body. One could then use the unsafe keyword to call the plain old C++ functions, or to turn safety features inside a safe function off for a block of code.
Isn't P minus P just
all old C++ code is considered unsafe. That's also why this proposal brings a new standard library in the std2 namespace.
If the standard was so good, why not make standard 2? They made standard 2. Standard 2 just dropped. It actually is that good. It's actually that good. You have to understand something, which is any set of functionality that lives on long enough will eventually have a number 2 version. It will, no matter what. It just happens every single time.
Which to my understanding will replace the whole standard library with safe alternatives. The proposal defines memory safety using the following categories. Lifetime safety, which basically addresses problems with using uninitialized variables, or for example, use after free bugs. To address this, Safe C++ will feature the borrow checker, which by the way a number of other languages also try to implement. Type safety, e.g. everything wrong with null, and to prevent this, the safe context will prevent the use of uninitialized variables and bring a new form of a destructive move called relocation, which means that you won't be able to use a variable after you move it. I suppose this is closely connected to borrow checker as well. Then
I wonder how bad the syntax will be for this. Because the thing about C++ is it's really, modern C++ is not a bad language. But it's just a language you type the word colon like 9,000 times. I feel like the syntax, I have like a pretty hard definition when I'm writing stuff, which is I don't like to exceed 80 characters. I know that's a lot of people are like, I know I do exceed it every now and then. I don't mind it. This is just like a general rule of mine, is that when I start exceeding this a bunch, it means I need to refactor. That's kind of like always been in my head. But when I write C++, it just has to be not that. I have to go to 120. There's no option. You can't help it. Same with Rust. Rust, I do the exact same thing. Rust, I also have to go higher, right? I have to go bigger because Rust has the exact same problem, which is just there's a whole bunch of colons. I'm also curious how they're going to enforce this, considering that C++ has only been really written in unsafe version or with unique pointers. And so it feels like unique pointers obviously would fit nicely into this safe paradigm. Same with shared pointers. They seem like they'd just fit nicely into this paradigm. But how much of this is how much of C++ is just raw dog and pointers everywhere? By the way, Dan actually is somebody that works in C++ all the time. That's his primary job. The issue, he went to one of my courses that I did for front-end masters, and he couldn't follow along because he didn't have Node installed. The bro's real, okay? Not a quiche eater. In fact, not a quiche eater. The issue is that most people don't use anything past C++ 14, except folks who really need the newest features, folks like high-frequency trading firms. So this is so if this has any overhead to it, I don't see it getting much adoption. I could be wrong, but just my opinion. And get deleted. Get timed out. Fucking Dan. That's a good reason. No, Node.js is based. It is. It is very, very based. So there you go. I just wanted to say that. Who's banned? You know who's banned. Anyway, so that's an interesting take. I'm just curious how do you, because I know working with Rust and any of the C libraries or C++ libraries, like though you can do FFI, like it all exists, there's a lot of glue and difficulty code. Are you going to get the same thing except just when you interact with other C++? Are you going to have a whole bunch of just stuff you have to do? Does that mean every pointer that comes into a safe function, you then need to convert into a unique pointer, or you need to convert it into something that is, safe? I don't know. I have no idea. Seems like a very difficult problem, and seems like you're going to get a lot of just code to make safe.
Thread safety talks, among other things, about data races and problems with classic synchronization.
I work in graphics. There's nothing but C++. I'm curious if Zig is actually going to make a dent in this. I am genuinely curious about Zig. It's the reason why I wanted to learn Zig for this exact reason, which is that Zig feels like the first language to actually make a step forward in the programming world that actually tracks and interacts with C and C++ in a real fashion, right? In a version that actually is useful. You don't have to do a whole bunch of crap to it. When Zig 1.0, that I don't know. I think that's Zig's biggest thing holding it back. Odin, I have not used Odin yet. That's why I said, do I use Odin? I'm just curious about that because Zig has all the same stuff.
Primitives such as mutexes. This will be addressed in the same way as in Rust as well, by using send and sync interfaces. To quote from the proposal, a type is send if it is safe to send it to another thread, and a type is sync if it is safe to share between threads. And finally, runtime safety.
How are they doing that? Because obviously there's traits in Rust. You have to do these attributes. Okay, do you have to do that to... Yeah, okay, that's interesting. So you have to throw on some attributes, and then I assume you can use concepts to kind of narrow down what is allowed.
Sync if it is safe to share between threads. And finally, runtime safety, such as inserting panics before index out of range and other bound checking of various types. But anyways, in my opinion, a Reddit user said it best. So here is a list of overall improvements from his point of view. Add a safe specifier in function signatures and unsafe block. Safe code bans a big pile of operations such as no pointer arithmetic, no pointer dereferencing, no pointer comparisons.
You can just say no pointer, right? Like that might be a little bit more useful for everybody. Sorry, dog, you can't just raw dog a pointer in here, okay? It's not gonna work, not gonna be happy.
No use of union members, no inline assembly, no use of uninitialized variables. They've added some new reference types that enable borrowing and borrow checking. Most types gain runtime bounce checking with the option to skip the bounce checks where performance really matters. Then there's the new operation DRP to call the destruction on a local object explicitly and set it back to the uninitialized state. Finally, thread safety guarantees based on Rust send and sync type traits. Personally, I like...
How is anyone going to program C++ without all these? I'm also curious about the reference type, because there has to be some way to relinquish a reference back out to unsafe C. So how do you know? My brain is just struggling, kind of chugging along in this point, which is how does it work, right? Like I can feel my brain just, right? There's references by doing it unsafe, so you can just unsafely return out a pointer instead of a reference. How does this add a new L value, R value, X value? Do we get a new one? Do we get like some new value, S value for safe value?
Guarantees based on Rust send and sync type traits. Personally, I like the idea overall, even though this is still not finished. I think that if the semantics and syntax will remain familiar to old C++ developers, C++ might actually remain relevant not just in the next 200 years, but also in the next 300. That said, I avoided showing you syntax examples from the proposal, since it's not 100% decided on yet. And to be frank, I'm not sold on the syntax.
That's not real. I don't believe it. I don't believe it. Back to Rust. I know, it looks worse than Rust. This actually looks significantly worse than Rust. This is Perl. This is a joke. We're getting joked on. This is just Perl. That's all it is. Everybody, this is just Perl. This is not real, okay? I refuse to believe that this is anything. The hat is AIDS. I know, what appears to be an XOR prefix operator after a star operator. This must be a reference. What the hell am I looking? Like, what is this? My entire existence is a lie. I'm just trying to like run this in my head. Okay, so we must dereference the pointer. No. Order of operations. It must be we increment the internal pointer. We then dereference that internal pointer. We then return that as a reference in an optional object. Did I get that correct? Am I now C++ master? This must not be XOR. Since it's a prefix operator, which I'm not even sure how you would parse that. Wait, there's also postfix. It has to stand for reference. How do you do an XOR operator then? How does it know that an XOR operator isn't a prefix operator? You're gonna have to parenthesis it, aren't you? You're gonna have to, you have to put parenthesis, dude. Monads are easier than this, I know. There's tildes. I assume it. Okay, so the tilde one I also am kind of confused as. I think the tilde does some sort of pointer casting. If you look earlier, under this one right here, under the attributes, you can query the interface values as T is send and T tilde is sync. So I assume right here, that's what it is. Now 0 will become a null pointer dereference, or XOR. Yeah, XOR will do something crazy.
To be frank, I'm not sold on the syntax. I still believe this is going into the right direction, and I wish these guys best of luck with the proposal. As I mentioned earlier, I'm also interested in how Carbon plans to address these things, for example. What do you think about the proposal? Is the change welcoming? Do you like?
Can I say one thing? Whoever made the Carbon logo is lazier than me. That is some lazy ass programming. Because earlier in this video, when it showed, dang it, I don't know where it was. It showed like a group of 3 languages. It had C in the middle, and I thought it was C. Yeah, I thought earlier this was C. I didn't understand it, and now look at us.
Carbon plans to address these things, for example. What do you think about the proposal? Is the change welcoming? Do you like it? Let me know in the comments below. And as always, I hope you guys had a good time. Thanks for watching, and I hope to see you again. Bye.
Bye. That was fantastic. What a great video. This accent and this voice, I swear, exists somewhere else, so I'm confused as to why I'm hearing it again. But I believe this is a new channel. Cheesed Up. Hey, everyone, go subscribe to Cheesed Up. That was great. That was a great video, by the way.